Uh, Hey there, so let's practice out a problem on the HackerRank. It's synchronous shopping. Cool. So the problem is Israel is a seaside city. Okay, Israel is a seaside city that has a number of shopping centers. Okay, and each city is connected by a directional route. Okay, so we have a number of shopping centers. They're connected by the bi-directional edges. They're connected by bi-directional edges. Each of which has a travel time associated with food. So we have a time associated with it, which is representing the travel time. Uh, each of the shopping center may have a fishmonger. Okay. Each shopping center may have a fishmonger who sells one or more kind of fish. Good. Two cats, one big cat and small cat are at shopping center one. Okay, so we are shopping center one. It's a cat and a big cat. We have a cat and a small cat and a big cat. Those are initially at the shopping center one. And they have a list of fish they want to purchase. Okay, so they have a list of fish which they want to purchase, and they also want to save the time. Cool. So they will divide the list between them. Great. So the list is divided between them. Determine the total travel time for the cats to purchase all the kinds of the fish. Finally, they need to meet at the shopping center and finally they need to meet at shopping center and cool. Great. So they need to meet at the shopping center uh, and one may arrive at the different times than the other. Cool. One may arrive earlier than the other one. The minimum time determined is when both have arrived at the destination. Cool. Okay, so they both have to reach the destination. It's not like that. If one of the cat has reached the destination, our answer is done. We have to wait for the both the cats to be reaching at the shopping center gate. Now, for example, and it goes to five shopping centers. K is equal to three types of fish. Okay. There are any shopping center selling K is equal to type of fish. The following graph is show a possible layout of the shopping center connected by M equals to 4 path. M equals to 4 path. Now each of the center is labeled as the center is being labeled as center number, fish types offered slash cats that visits. Okay, so we have the each center is labeled by like a okay. So there's a label which is given for each center, which represent the fish type offered, and the cat which visited, like the big one or the small one. The BLN represent the big cat and the little cat, respectively. In this example, both cat take the same path, that is 135, and arrive at the time 20 seconds. They have purchased all the three kinds of the fish they wanted. Okay. They want the fish to be buyed. They want the fish to be buyed. Uh, okay, so this is the example which is given to me. Okay, so the n is equals to 5. So let's mark n is equal to 5. We can see that there are 5 nodes. 1, 2, 3, 4, 5. And we have k is equal to three types of fish. The shopping centers selling k is equal to three types of fish. Great. They are selling three types of fish. They are selling three type of fish. So k is equals to so k equals to 3 is needed. Yes. K is equals to 3. K equals to 3. Um, um, where they both are okay. They both are at the center one. They both are at the center one. Right. Okay. So the first center is saying that it is the center number one. and we have big, big cat. We have a big cat. It is selling the type one of the. It is selling the type one of the uh, fish. Then we have the this shopping center three, which is having 23 return on it, and it is having BL. It will represent the I would say 2 and 3, I guess 2 and 3 type of. So okay, so up to here, we can simply see that 1 and 2 and 3 types. Only the type 3 is associated with this very fellow. The type 3 is associated with this very fellow. Over here, we have 1 and 2. Over here, we have only two. And we are starting with one. Okay, definitely. So the one is definitely being collected. The one is definitely being collected. And here we have slash. I think this is the solution. I think this is the solution. Like the big cat will flow like this, and the lower cat is also like flowing like this. Big and low both will take this path. Big and the small one both will take this path, because this is the only path in which the which is definitely the shortest one, and also it is offering both the kind of all the three kind of the fish, right? Okay, so the functional description which we are having is okay. So the function description, complete the function shopping in editor below. Great. Oh, okay, it should return an integer. Function will return an integer, which is representing the minimum time required for the shopping grid, and we have the following parameters, and which is the number of shopping centers, where you an integer, the type of fish, number of types of fish, centers, the an array of string separated, it will be an array of strings. It will be an array of strings. So it will be an array of strings of space centered integer, where the first integer isn't center are an array of strings. Okay. Okay. So, okay, yeah. So it will be like an array which will store the information, and everything is stored in the form of the like strings. And we have a string, and we have the space separate integer. The first integer is the number of elements in the. Okay. So first integer is each element the number of type of fish. Okay. Number of types of fish. Okay. The first integer represents the number of types of fish which are sold at the center, and the remainder are the type of the fish which are being sold. Great. Uh, we have rows. The two-dimensional array of integers with first depend on the center. Okay, so this is the edge information. This is the edge information, and this is like the centers are represented like this. And we also have k, which is an integer number of the types of fish, and we have integer n, which will represent the number of the shopping centers. Cool. Great. So this is the function description. And now what is the input format? The first line can two separate integers and m and k, number of shopping center, m the number of rows, and k the type of fish sold in the bitcoin respectively. I of the n line, the line of the space separated integers. Okay, so we have like n shopping centers, right? We have like n shopping centers, each line I of the n subsequent line. Okay, so we are having n subsequent line. Describe the shopping center in the line of the space separated into each line is the form. First, it is the number of types of fish that were sold, and I shopping center. Each of the TI subsequent integers describe the type of fish sold by the fish smaller, represented by AI Z, which are represented by AI Z. Great. So each of the TI is each of the TI is an integer, and the line describes the translation by the words denoted by AIC. Okay, AIC. Equals integer TI. Okay, so I. Okay. Yes. It will represent like three. That means like three. Wait. And what's it? AIZ. AIZ I is the shopping center, and Z is the number, and from index I to T of I, like from index I to like index I to like T of I. Uh, if we have like five, Then our indexes will go like 0, 1, 2, 3, 4, 5. Great, like we have like 0, 1, 2, 3, 4, 5. Okay, and 1 to 5 will is representing the kind of the fish that are sold. Okay. Each line J of the subsequent line, cool. The each line J of the subsequent line contain three spaces of an integer. Okay, U to V, uh, and amount of the time, which is that, right? Each line J. Okay, so then we are having like subsequent lines, then we are having subsequent lines, uh, which will give us the three value, the U, V, and the time. Okay. Most important is the constraint. Is the constraint. Okay, so we have 10 to the power of 3 nodes. We have 10 to the power of 3 nodes. And still 10 to the power of 3. So, okay, or like 10 to the power of 3 of n and m edges and nodes. We have k. Okay, so 1 to 10. Okay, so we have like 10 kind of fish. We have 10 kind of fish. Okay, now here is, yeah, uh, 1 to 10. Okay, so k is 1 to 10. Cool. So k is 1 to 10, and these are some of the constraints. It should connect to distant shopping center, no road connect to shopping center to itself. Okay, so they're basically saying that all the edges which are given are basically valid one. All the edges that are given are simply representing the valid one. Great. Uh, uh, cool. So, um, okay, so the outward minimum number of time. Good. Okay. So this is another explanation. Okay, so this is the test case. We have five shopping centers. We have each are sounding like 1, 2, 3, 4, 5. Each center specifically. So we need to travel all the path. Like we need to travel all the path, right? We need to travel all the path. We need to travel all the path. We cannot skip any of the path. Uh, okay, so we need to speak. We cannot speak. We cannot uh, skip any of the path. And so we have two camps. We have two cars, and the both can split the path. They both can be like split it into two different parts. And so we have two cars, and both can split the path. Both can split the paths. Both can split the path. Cool. So like we have 10 path, and both can like split the path. They can have the list. They can have the list with them. List. They can have the list with them. Great. So they can like have the list with them. Oh, cool. Okay. So one thing which I got to realize from the tag of the problem is that uh, it is having a bit mask. Bit mask is simply we can try out all the possible arrangements. We can try out all the possible arrangements of the tan in a 10-bit number. We can try out all the possible arrangements. We can try out all the possible arrangement in a 10-bit number. So like we can try out all the possible arrangement in a 10-bit number. Cool. So we can like try out all the we can like try out all the possible arrangement in a 10-bit number, right? And so we can like pass out all the possible arrangement in a 10-bit number. We can like split the Cool. So we can like split the list which we are having, and each of the fellow is having a specific task. Each of the fellow is now having the specific task. Okay. So each fellow is having a specific task. Now, let's take this example only. Both of them are sending at this, and one like 2 and 4, like 2 and 4, or like 2 and 4 are represented in this upper region, like 2 and 4 kind type of fish are represented in the upper region, and like this region is representing Okay, so like 213 is representing this region and like this and this representing this region. Okay, so the path have to be splitted, the path have to be simply we have to split the path for this fellow. Okay, okay. One of the edge cases, if my is I think I think we need to collect all the kind of fish. I think we need to collect all the K kind of fish. Right? Okay. So if one is having all the K type of the fish with it, or like the another guy is having all the K kind of fish in it, then if we can just have the shortest path. Like we can just have the shortest path from we can have the shortest path from this fellow to this fellow. Or we can have the shortest path. We can have the shortest path from this fellow to this fellow, reaching out the destination. Reaching out the destination. Cool. Great, 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 great. Yeah. So great. We can simply have this particular part, which each of the fellow can use to your own goal. Which part which each of the fellow can use. Also, here we have this part which is all. We have a list. We have a list with us. Like for all the bits, like so, like so for all the bit number which you have, like for all the bit number which you have, you just find out the minimum in that. We have to find out the minimum of that. Uh, Select for all the bit number and all the like possible arrangement of the. We have to find the time. We have to find the shortest time. We have to find the shortest time. We have to find the shortest time for this follow and this follow. We have to like find the shortest time for this follow and this follow to reach out the destination. To reach out the destination. Uh, Okay, so we have to tools so we have to like so we are like starting this project need to be followed and have it uh, so now this like how would I do it actually that's good. How is the main question? So like, how will I, how will I just simplify the answer? Like, how will I simplify the answer? It should be, uh, like for my first, for my first, for my first fish. Okay, so for my first fish, I can see at each node is having some of the is having some of the fishes available, so I can also create a smaller bit mask for those. And there is I can also keep a mask collected, and like I can like one of the ways is like let's say we have the lower cat and it will like go through all the nodes in any of the path. Like the main function of this would be like just to go and reach down to the fifth shopping center, like the NS shopping center, and wherever it will go, it will just collect the fishes which were encountered, and also like trace the path which it have, and also like trace the path which it have it like also like trace the path which it have, and also like for this fellow also we can like just go to the path and trace all the fishes it can collect, because there is no harm in collection. There is no harm in collection. So the mask can be updated, and at the end, both the mask of the big cat and the small cat can be merged down, and uh, it should finally reach to the desired uh, mask which we needed. It will just reach to the desired mask which we needed. We will be having uh, DFS. So like, we can like have a DFS for this fellow. Like we can have a DFS for. Okay, so like there is no gain in revisiting a particular node. So like we can follow a DFS for this fellow, and we can also have the DFS for the another fellow, and we can like reach the destination. Okay, so but we also wanted one thing. We also wanted one thing that the but we also wanted one thing that but we also wanted the path to be minimum. So we need some of the something like a shortest path. Like we need something like the shortest path algorithm. We all know it's Dijkstra, but how will we implement like the Dijkstra? Uh, Dijkstra will Dijkstra will tell me the minimum. Like Dijkstra will tell me like the minimum path for from this fellow to the destination. The minimum time it will require from minimum time it will take from minimum time it will take to reach the destination, minimum time it will take to reach the destination. But that should also fulfill our goals, but that should also fulfill our goals. And also, and also the shortest path is, it may happen that the shortest path can have everyone, and we can have a more increased time. But we need to ensure that we collect down all the fishes. We need to ensure that we collect down all the fishes. So that, so like if I use this stuff, like if I use a priority queue, if I use a priority queue, if I use the priority queue is having the priority queue is having something. Priority queue is having something like the topmost car. Like priority queue is having something like the topmost, like the shortest thing, like contain like priority queue. Yeah. So like we can have the priority queue which will contain the shortest stuff. So we have ideas of different ways, then we definitely need to have the priority queue. We definitely need to have the priority queue. like priority queue will help me. Priority queue will help me reach down to the final destination. Like priority queue will help me. Priority queue will help me reach down to the final destination. Reach down to the final destination. Like we definitely have to reach the final destination, and in one of the like shortest manner, we one of the like shortest, like whenever. Cool. So we somehow need to reach the destination. We somehow need to reach the destination, and if we use a priority queue, we will reach the destination, and it will happen that we will reach a particular destination more than single time with a bit enhanced time, with a bit enhanced time. Uh, and I can like each time whenever I reach the destination, I can like it will give me it will give me a bit mask. It will give me a mask value, and I can just I can just store somewhere. I can just store the I can just somewhere store the mask value and the time I have taken down to reach, like the mask value and the time taken by it to reach. And similarly, like I can also similarly like I can do it like similar like I can do it for the other cat as well, for the other cat as well. Okay, okay, okay. So similarly, I can do it for the other cat as well. Similarly, yeah. So similarly, I can do it for the other cat as well. Uh, so basically, I will at the end I will like having a list of the values, like having a list of the values which are uh, and I can just pair up pair up like I need like two stuffs. Like I need two stuff. Okay. I need like two pack, and I can like pair up the every two pack which I have generated. Like I can just okay. So like I can just pair up two paths which I have generated, and if the mask is the desired one, I can just minimize my time as per my list. Okay. So uh yeah, we can proceed in the direction. Like let's say we can proceed in the direction. Going right. So let's continue. Cool. Uh, yeah, so let's settle about it. Like, okay, so first of all, see, first of all, each each shopping center is having some desired mask. It is having some mask. Why I'm saying so? Each shopping center will have a desired mask, which will represent the kind of fish it have. So mask can like we have 10 kind of fish. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, yeah. So let's say the we can have like 11 bits. Create. So we can like create something like a map, or we can create something like a map of let's say my mask will be long. Like I don't want any problem that I encountered in the midway. I don't want any problem to be encountered. So let's quickly do that, right? So we have the center side. So what is stands for the stones and specific integers. We're gonna move in left. We have value which will return into the centers and it's the percentage will be correspond to the of the higher center so integer line is equal to this so okay, so now from first of all, yeah, also I will keep that and this is equals to like the 0 1 to the level as yeah, and I will keep the mask long and escape. Is to do um, escape what's it called teacher time escape short as simple on skill skill set the grid and set this variable which is which was like shift for sort for handy minus zero um, this is how I will get business and map off for the center number center number is oh sorry so this one is something so now I have the mask of the centers ready with me and I will I will have the practical um, practical will be practical will be having the practical will be having three steps. First will be my distance distance practical will be having like three steps and the first one will be like my distance and the later two will be my center number and my mask which I'm carrying up the perspective which will be required that always the way and again it was that and it will long uh, we need to carefully observe it once. Okay, so this fellow, okay, so this fellow, okay, so this is my like base quantity. Okay, for inside this, I have base quantity, where I have this base quantity, and what is substance? I think it's okay. So now we will have the push of push into the so the push push is your letter this one and then one node number. So this is zero. This would be one, and this would be mass, which will be zero. Okay. One, keep us to I can use the I need time and I need two steps. I need what are the two steps which I need just telling people what are the two steps which I need. This will I don't know I will do I'm getting the mask along with the time right. It's in my okay, store. Let's just call this thing. Uh, it will be integer of time is equal to like equals to integer is equals to y to the first one to finish to it. It's just without first sorry second so I'm not breaking it. I'm not breaking it up. I will push into the conductor. I will just push into the reference. I need to create the You will create the desired mask. So, so basically the code is written. Let's run it. Maybe initially. Uh, okay, so let me just fix my field. Here, okay. So let's run the code for chicken. Okay, so we are having your sign out the errors. It says we have line 20 comparison of the string expression of different as integer string character. Okay, so this is their character. So line number 20, I guess the person has was going to copy. It would be this only. It says S was not declared in this code. Okay, okay, okay. So S was not declared in this code. Okay. Okay. So, so next one with that, version of distance version of different signless of the intermediate and studio string of string of back or line 53. That is the reverse. Okay, okay. I just answered one more quicker. I just answered this one more quicker. So let me just quickly create my adjacency list somewhere in the initial stage only. So it's by direction, so I will just go in the directions. So now, that's so these are warning, these are warning. Okay, so this is error H1. This is no matching function to follow. Into min of this max. Unit of time is equals to minimum output. Please back. It's long on the end. So mask is first, and this is second. So mask is like first. This is like second. So it is bad along. It is bad along. Uh, aren't we going having the out of range for the range? Okay, so we need to see the visitor. It would be initially map of one. So we have to keep a track of the state, right? Instead of this, I will do visit of I think this also need the mask because if we only restrict the shorter distance, then maybe the mask is also one uh, and this would be I feel vector this particularly what we're having the distance, right? With the declaration of the distance, with the declaration of the distance, uh, yeah, so it would be what kind of vector or I would say it must preferably it would be a long one, right? Um, it don't need to be it doesn't need to be a long, it can only simply be a right? But it needs to be a good value. But this particularly this particularly this this one vector and over here I need the big ones. One, two, this would be like the biggest mask which can be there. So it will choose to power 11, right? Because up to 10 we have finally this is at least these two test cases are let's see. Okay, it fail on some of the test case. So I the little bit of there are little few bugs remaining which needs to be fixed. Okay, so it would be first of all NMSK. It would be NMSK, and we don't explicitly need a visited. We do not explicitly need a visitor because the in standard priority queue we do in standard text algorithm we do not use the visited because the visited can restrain some of the answers, right? The visited can restrain some of our answer. So when you to put a check upon there, um, where the visitor, let's just remove this visitor. After it, let's just remove this visitor. Let's just remove this visitor concept. Um, let's remove this as well because actually we don't need this is stuff. I just need to go for basically my answer would be uh, mask one, right? Uh, like the the nth fellow, The D of N is considered is having all the mask, and this can be like I can be mask one. So it can be one, it can be one mask, or it can be another mask. It would be I. Sure. And if both are equal, we will be having a D of N for the I, D of I for the J. We need to add this middle line as well. Let's see. I'm saying if this is not reachable, if D of N I is equals to influx, or my D of N G equals to influx, when I can continue. Uh, and instead of this 11, this is the first place. 11 is for the worst place. Very, very big blunder which you're doing is this strategy of creating a mask for the fellows, right? This particular stuff. We can like create like the string like token. We can like create tokens, and we can use a split function, uh, right? And the length will be this. Oh, so finally the problem is submitted. I hope you understand the solution. Thank you.